Welcome back, mathematicians. In this video, we are going to solve quadratic equations in the complex number system. Because of the fact that we're solving in the complex number system, there's a very real possibility that our solution will contain an imaginary part. For this reason, I'm going to choose not to factor because some of these are likely to not be factorable. Instead, I'm going to focus on possibly one of two strategies. The first one could be completing the squares, and that's a great strategy to use. However, I'm going to go with option 2, which is to use the quadratic formula. Both of these will work and will result in a solution to any quadratic equation. So the first one is x squared plus 4x plus 5 is equal to 0. Using the quadratic formula, we have x is equal to opposite of b, which is negative 4, plus or minus the square root of b squared, which is 4 squared, minus 4 times a, which is 1, times c, which is 5. And this is all over 2 times a, which is 1. Now we simplify the expression under the radical, and we get x is equal to negative 4 plus or minus the square root of b squared is 16, minus 4 times 1 times 5. So negative 4 times 1 times 5 is negative 20, or minus 20, all over 2. Keeping this going, we have negative 4 plus or minus the square root of negative 4, all over 2. Now here's where if we were solving this in the set of real numbers, we would stop and say that there is no solution, because in the set of real numbers, we are not able to square root a negative value. But in the complex number system, we can. And so we say x is equal to negative 4 plus or minus 2i all over 2. Now because we have a common factor in our numerator and denominator, we should reduce. So we're going to factor out positive 2 from the numerator. So we'll have 2 times, and the other factor will be negative 2 plus or minus I. And from here we can reduce that common factor, giving us a solution of negative 2 plus or minus I. Let's go to example number 2. Now this one is a little different, and you'll notice that in this example, our b term is equal to 0. In other words, we don't have a linear term for this quadratic equation. As a result of this, we could use completing the squares. We could also use the quadratic formula. However, there's a slightly faster way to go about this whenever b is equal to 0 or you're missing your linear term. And that is to subtract 32 to both sides, giving us an equation of x squared is equal to negative 32, and then taking the square root of both sides to undo the squared. And so what we get is x is equal to. Now anytime we perform a square root on both sides of an equation to solve for a variable, we need to include a plus or minus away from the power that we are trying to undo. And now we have the square root of negative 32. So one more time, because that value is negative, if the directions were asking us in the real number system, we would say there's no real solution. However, the complex number system, there is. So we need to simplify this radical. So we'll say x is equal to plus or minus, and now I'm thinking of a perfect square that is a factor of 32. There's actually two. We could say 4 or we could say 16, but we want to choose the largest one. So I'm going to say negative 16, and then we would multiply that by a value of 2. Well, the square root of negative 16 in the complex number system is going to be 4i, and then we have times the square root of 2. And so this is your solution. Now you can order this however you'd like to. If you can put the I last if you would prefer. I tend to prefer to keep it between the 4 and the square root, because otherwise it tends to look like it might be underneath the radical. But both of those are correct. All right, guys, good luck.